Okay, so I'm going to be looking at the Noma LED A-socket bulbs here. I had a couple of these in my bathroom. It seems to be the torture test for LED bulbs. I've gone through two other brands and have not had a lot of success with them not failing. Had Korea in there. I had, I forget what the other one was. I broke it down anyways. So these guys, like I said, are Noma, and feels like plastic case, and yeah. Anyways, we're going to tear this apart and see what makes it tick. Okay, so I just removed the hot and neutral side of the controller. Now this has really got very little in it. Um, yeah, like wow. I have never seen so little in a friggin' LED bulb. Anyway, so I'm going to work on removing the LED mounting plate. Like already I can tell that like this is an incredibly cheap made bulb. The controller is one thing. From what I can see, unless they've got the current source controller on the main IMS material that the LEDs are mounted on, I'm going to say that this is probably one of the worst made bulbs I've taken apart so far. I gotta say though, it's simple, but having a resistor as your current limiting is terrible. You know, the effects of temperature on light output is huge because it's not controlling the current very well. It's basically fluctuating with the forward voltage of the LEDs as temperature changes, and I mean that's just awful design. However, it can't get much cheaper. Anyway, so I'm going to work on removing the lens here, or diffuser, and then we should see what's on the backside here where the LEDs are mounted. And there it is. It is, geez, I can't even say what that is. So I have to take a look a little bit further to see what this is, whether it's some sort of regulator, high voltage regulator, or if it is a blocking diode. But again, compared to the other manufacturers, there's very little in this, and heat sinking wise, bare minimum. You've got the IMS material, so this will be an aluminum plate that has an insulation material on it, and then the copper traces, and the LEDs mounted on top, so the top components. So we'll just take off. There's normally some sort of goop underneath it, thermal paste, that will make contact between the IMS material and the aluminum plate, or the aluminum casing. But yeah. So like the other manufacturers, there's like bare minimum under there. You can see that there's good sections of it where there's nothing at all, which means that the thermal resistance between this heat or the IMS material and the heat spreader on the back, which is pulling the heat from the IMS, again the thermal resistance is very high, which means that the heat is not as easily traveled through that boundary, and the LEDs will get much hotter. The other thing I've noted is that there is a major warpage here on the IMS material. That usually presents a problem, especially under thermal cycling and where there's moisture involved, because as soon as you start bending that aluminum substrate, you start cracking the material, the insulation material, and then once there's a micro crack in it and moisture gets in, it starts affecting it. So it wouldn't surprise me that we have some places on here where we've started to get some sort of formation growths from the moisture. But I'm going to take a look at this a little bit further and see what we actually have here, if there's any labeling on this at all, and I'll take a meter to it and just take a look at it to see if I can figure out what it is. Yeah, inspecting the IMS material itself, there's a whole whack of cracks in it, and it looks like that we had some overheating occur. The insulation on the wire feeding up, like from the rectifier here, which I believe that's all it is. Yeah, so I think this is just a rectifier, MB10S, or MR, it's MR. And it looks like a 4.7 ohm resistor in series, and an 8.2 microfarad outer lytic. Fairly cheap. Now let's see. I'm going to guess that this was, and I'm really just taking a guess because two of the terminals are shorted, and one is showing a diode in forward, and it looks like a Zener in reverse. So and the rep does is U1 on it, so can't really tell. It could be a high voltage regulator. Anyways, so what's the failure mode on this? That's one thing that when I look at this, I don't know if I can get a picture of the what the IMS material looks like. I'll put it on there so it can be seen. But again, it's high cracking around where the U1 is and where the wires for, I guess it's from the bridge rectifier, come up, and you know, there potentially could be shorts in between. Like, I mean, I should check that. So we don't have any shorts on the plus and the minus, but in the diodes themselves, they're probably like 5 volt forward bias. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, so 75 volts. All right, we'll do some more investigation.
Okay, so I took the board, the main LED board, and tested each individual LED with a voltage supply. It dialed it up until it just lit, and measuring that voltage was approximately 8 volts, so this is just barely at threshold voltages for that particular diode. That's much higher than I was expecting. I did go through each diode and found one that had a black mark on the lens portion of the LED, and the diode would not light up, so it appeared to be the failure point of the bulb, since all these all these LEDs are in series with the current source. After looking up on the web, I kind of figured that what we're dealing with is a current source that is kind of like a big zener in a sense, or almost like a zener in how it regulates the voltage. In this case, it's regulating the current. And again, this is a very simple design, as long as the LED do not require a large amount of current. Once your current starts to get larger, then a linear mode controller like this becomes less efficient. Things that were noted were quite a bit of heating effects on the IMS material. So a lot of cracking, and the positive wire feed from the bridge rectifier was melted off the insulation, which again is another indication of high heat for prolonged periods of time. So, you know, as normal, almost all these bulbs that I examine all fail from thermal effects. You don't see just random, systemic component failures, fortunately. So really how these bulbs are used really gets or affects their lifetime. Any place where there is excessive heat being trapped, you're guaranteed to be having a very short lifetime for the bulb. And that's partly the manufacturer's fault, because they don't design these things to have much heat sinking at all. When Philips originally brought out the LED bulbs with the yellowish lenses, they were well heat sunk, and they're heavy, and they're also very expensive. But I still have every single one of those bulbs I purchased many years ago, and none have failed, although I have one that's starting to fail a little bit. But they've been pretty rock solid compared to these cheaper bulbs that just don't have the thermal characteristics for, you know, being used in most of the applications where the bulb's going to be trapping heat in the fixture. So, would I recommend the Noma bulbs? No, not for anything that's going to be where there's going to be heat being trapped. But I can't say that they're any worse off than the other manufacturers. And if anything, I can see that they're very cheap in how they've been made. So that would mean that you're probably going to be able to replace these things fairly often because they're going to be relatively inexpensive.